Hi, welcome back to our channel. The next lesson is about rational numbers. Specifically, its fractions to decimals. Are you ready to learn? Let us first talk about rational numbers. Rational numbers are denoted by letter Q. Let us start with positive integers, also known as natural numbers or counting numbers. They are denoted by letter N. These are 1, 2, 3, and so on. We also know 0. If we're going to combine 0 and the positive integers, we can form what we call whole numbers. In our number line, on the right side of 0, we have the positive integers. And on the left side of 0, we have the additive inverse of our positive integers. They are called negative integers. Examples: -1, -2, -3, and so on. If we're going to combine the negative integers and the whole numbers, we will have what we call integers. They are denoted by letter Z. If they are not integers, they can be non-integers. So what are non-integers? Non-integers are fractions and decimals. Fractions that can be converted into decimals, and decimals that can be converted into fractions. We already studied about fractions. We know that there are proper, improper, and mixed fractions. We know that there are like or similar fractions and unlike and dissimilar fractions, and also equivalent fractions. For the decimals, we will be learning about the terminating decimals and the non-terminating and repeating, or what we call recurring decimals. If we're going to combine all of these, we can have what we call rational numbers. Rational numbers can be written as quotient of two integers. They can be expressed as fractions and decimals. In symbols, a over b, where b is not equal to 0. A decimal is rational if it is a terminating decimal or it is a non-terminating and repeating decimal. Let us convert these fractions to terminating decimals. 1/2. We have to divide 1 by 2. 1 divided by 2 is 0. 0 times 2 is 0. And then 1 minus 0 is 1. Then we add decimal point and 0. Bring down 0. 10 divided by 2 is 5. 5 times 2 is 10. You subtract 10 minus 10 is 0. Therefore, 1/2 is equal to 0.5 or 5/10. Next, we have 3/8 or 3 over 8. We divide 3 by 8. 3 divided by 8 is 0. 0 times 8 is 0. We subtract. 3 minus 0 is 3. We add a decimal point and 0. We bring down 0. 30 divided by 8 is 3. 3 times 8 is 24. Then we subtract. 30 minus 24 will give us 6. We are not done yet, so we add another 0. Bring down 0. 60 divided by 8 is 7. 7 times 8 is 56. Then we subtract. 60 minus 56 is 4. We still have a remainder, so we add another 0, and then we bring down 0. 40 divided by 8 is 5. 5 times 8 is 40. Then, we subtract. 40 minus 40 is 0. We are done dividing. Therefore, 3/8 or 3 over 8 is equal to 0.375 or 375 thousandths. Next examples for fractions to terminating decimals. This time, we don't have to divide the numerator by 10. We don't need to move the decimal place to the left. We just need to follow our decimal value. Next will be fractions to non-terminating and repeating decimals. Example, 2/3. Let us divide 2 by 3. 2 divided by 3 is 0. 0 times 3 is 0. And then you subtract. 2 minus 0 is 2. We add a decimal point and a 0. We bring down the 0. 20 divided by 3 is 6. 6 times 3 is 18. And then we subtract. 20 minus 18 will give us 2. There is a remainder. Therefore, we need to add another 0 and bring it down. 20 divided by 3 is again 6. 6 times 3 is again 18. And then we subtract again. 20 minus 18 will give us 2. There is a remainder of 2, so we need to add another 0 and bring down 0. As you can see, we have 20 again. So if we're going to divide 20 by 3, it will also give us 6. So the answer will be 0.666666, and so on. Since our 6 is repeated continuously, we can write our final answer as 0.6 bar. This means that 6 is repeated continuously. Next example, 5 over 11. Let us divide 5 by 11. 5 divided by 11 is 0. 0 times 11 is 0. And then subtract. 5 minus 0 is 5. Add a decimal point and a 0. Bring down 0. 50 divided by 11 is 4. 4 times 11 is 44. Subtract. 50 minus 44 will give us 6. There is a remainder, so we add another 0 and we bring it down. 60 divided by 11 is 5. 5 times 11 is 55. Then we subtract. 60 minus 55 will give us 5. There is a remainder, so we add another 0. And then we bring it down. 50 divided by 11 is 4. 4 times 11 is 44. Then we subtract. The answer will be 6. Since we have a remainder of 6, we add another 0 and we bring it down. 60 divided by 11 is 5. 5 times 11 is 55. Then we subtract again. 60 minus 55 is 5. There is also a remainder of 5. So if we're going to add another 0 and bring it down, it will become 50. And as you can see, the answer is 0.45, 45, and it will continue as 45, 45, and so on. Since 45 is repeated continuously, we can write our answer as 0.45 bar. This means that 45 is repeated continuously. Last example for fractions to non-terminating and repeating decimals. 13 over 15 means we have to divide 13 by 15. 13 divided by 15 is 0. 0 times 15 is 0. We subtract. 13 minus 0 is 13. And then we add a decimal point and a 0. We bring down the 0. 130 divided by 15 is 8. 8 times 15 is 120. Subtract 130 minus 120 is 10. We have a remainder, so we add another 0 and we bring it down. 100 divided by 15 is 6. 6 times 15 is 90. Subtract 100 minus 90 is 10. We have a remainder again, so we add another 0 and we bring it down. 100 divided by 15 is again 6. 6 times 15 is again 90. And we subtract. The remainder is again 10. As you can see, our 6 is repeated continuously. So the answer 0.8666 and so on can be written as 0.86 bar. The bar is in our number 6 only. This indicates that 6 is repeated continuously. Remember, rational numbers can be written as a over b where b is not equal to 0. 5 is a rational number because it can be written as 5 over 1. Negative 5 is a rational number because it can be written as negative 5 over 1. 0 over 5 is also rational because 0 over 5 or 0 divided by 5 is equal to 0. But 5 over 0 is neither rational nor irrational. The result is called undefined. Thank you! I hope you enjoyed our lesson today. Please like, subscribe, and share.